simplifying expressions using sum and difference identities. We want to simplify each expression here. Let's take a look at example A. Of course, it looks like a big mess. There's lots of different pieces here. What would I do to clean this up? Well, what I'm supposed to notice is, gee, this pattern looks familiar. Sine something, cosine something, minus cosine something, sine something. I feel like I've seen that before. In fact, I believe it's related to one of our sum and difference identities. Let me go back to those. Let's see. Aha. Sine something, cosine something, minus cosine something, sine something. It's the right side of the difference identity for the sine function, which means I can replace this right side with this simpler left side. Sine alpha cosine beta minus cosine alpha sine beta. If I see that pattern, I can rewrite it sine alpha minus beta. So back to our problem, 3k would be the alpha, k would be the beta. This fits the pattern, sine alpha cosine beta minus cosine alpha sine beta. According to the identity, this is equal to the sine ratio of the difference between those angles, alpha minus beta, 3k minus k. Well, 3k minus k, those are like terms. 3k minus 1k is just 2k. And I have simplified the original expression. Let's take a look at the second example. The second example is a more straightforward usage of the sum and difference identities because right off the bat I see that I have the cosine ratio of a difference. Remember, each of these things here is an angle. In fact, we sometimes like to read this, the angle whose sine ratio is x, or the angle whose cosine ratio is x. Well, that's exactly what the cosine difference identity deals with, the cosine of one angle minus another angle. Let's remind ourselves what that identity says. Let's see, that's the one with the red box here. The cosine of a difference is equal to cosine first, cosine second, plus sine first, sine second. And so let's use that to rewrite this expression. Cosine first, the first angle is sine inverse x, times cosine second. This is the one where the sign, S-I-G-N, changes in the middle, so I have a plus, and then it's sine first times sine second. At first glance, this looks pretty messy, but we've learned how to deal with compositions of trig functions and their inverses. We have 4 pieces here to work out. A couple of them are very easy. This one here, cosine and cosine inverse, they just wipe each other out. So that's just going to be x. The same thing happens with sine and sine inverse. They're just going to wipe each other out. They're inverse functions. That's also just x. It's these other two at the edges that I'm going to have to deal with next. So let's take a look at cosine of sine inverse of x. This is telling me find the cosine ratio of the angle whose sine ratio is x. I'll have to draw that out. Now we're assuming here that x is a valid ratio, that it's positive, that we're in the first quadrant. It doesn't really look like a ratio. Maybe I'll put a 1 under it to make it look like a ratio. I'm drawing the angle whose sine ratio is x over 1, opposite over hypotenuse. Here's the angle in question. Of course, what I want is not that angle. I want the cosine ratio of that angle. Well, that's going to require me to find this missing side. Let me temporarily call that side a. I would know that a squared plus x squared is equal to 1 squared. In other words, a squared, let me move that x squared to the other side. 1 squared is 1, minus x squared to the other side, and then square root each side. Everybody's positive in the first quadrant. There's no way to simplify that square root. And so I end up that a is equal to the square root of 1 minus x squared. Well, now I can come back over here and I know what my cosine ratio is. It's adjacent over hypotenuse. The 1 doesn't even do anything, so it's just going to be square root 1 minus x squared. Okay, then we have this last piece down here. It's very similar. I want the sine ratio of the angle whose cosine ratio is x. I can draw a very similar picture. Again, we're assuming first quadrant, positive x. If the cosine ratio is x over 1, my picture will look like this. I'll still have to solve for that missing side. Do you see that the math will be exactly the same? I'm going to get the same answer. It's still going to be the square root of 1 minus x squared. Well, that means the sine ratio is opposite over hypotenuse. Dividing by 1 doesn't do anything, so I just have square root of 1 minus x squared. How can I simplify this? This is x square root 1 minus x squared plus another x square root 1 minus x squared for a total of 2x square root 1 minus x squared. That's as simple as we can make it. We've taken a very complicated trig expression involving even inverse trig functions and written it without even including a trig function. Thanks for watching.